Hey guys, Mr. Milton here. Today we're going to look at solving system word problems. At the end of this video, you should be able to write a system of equations from a word problem, and you should be able to use or solve word problems involving systems. So here's our process, guys. We are going to define our variables, use what you know to write two equations, and then solve the system of equations using either substitution or elimination. Okay, remember that graphing probably is going to be the least efficient way for us to solve these. Okay, so let's look at this first problem. It says the Colts have scored 225 points this season so far. The number of touchdowns is 3 more than double the number of field goals. Assume they have only scored on touchdown 7 points and field goals 3 points. Okay, how many touchdowns have the Colts scored? How many field goals? So there are two variables that we have to deal with. T for touchdowns and F for field goals. All right. So they gave us basically, the thing that's helpful for me to think is they always have to give us enough information to write two equations. If they don't, then we can't solve it, and it's a bad problem. Okay, so know that you're not going to get bad problems here. You've got to have enough information to write your equations. So the number of touchdowns is 3 more than double the number of field goals. That is an algebraic expression hiding in there. Okay, the number of touchdowns is, so remember that T stood for the number of touchdowns. The number of touchdowns is 3 more than double the number of field goals. 3 more than double. So double the number of field goals plus 3. And there we have it. That's one equation. The number of touchdowns is double the number, or 3 more than double the number of field goals. Secondly, it says, assume that they've only scored on touchdowns 7 and field goals 3. It's scored 225. So they've given us an equation about points. Okay, so there's 225 points, and they scored 7 per touchdown and 3 per field goal. And now we have a system of equations. Okay. Setting up the system of equations should be the most difficult part about this, because the rest of it's kind of a review of stuff that we already walked through. Okay. The second most difficult part is choosing which method you want to use. Either method works out fine, but sometimes you'll do a lot of heavy lifting to try to get it to one method if it doesn't fit. So this problem is really made to be solved with substitution. And we can tell because there's a variable that's by itself in T. T is already by itself, so we'll want to solve using substitution. And so what we're going to do is we're going to say T equals 2f plus 3, or T is the same as 2f plus 3. So in our second equation, instead of using T, I'm going to use 2f plus 3. So 225 equals 7, and then I'm going to substitute 2f plus 3 in for T, plus 3f. All right, so 225 equals 14f plus 21 plus 3f. Combine my like terms, 225 equals 17f plus 21. Subtract 21 from both sides. And I have 17f equals 204. See if that goes divided evenly. I'm sure it does. 17, and that's 12. Great. That's nice. So it says that the Colts scored 12 field goals. All right. And now that we have that answer, we need to know how many touchdowns we scored. Well, we say touchdowns was 3 more than twice the number of field goals. So 24 plus 3, 27. 27 touchdowns. All right. Next problem says Tyler and Stephanie bought some DVDs and Blu-rays during the Black Friday sales this past Friday. Tyler bought 12 DVDs and 5 Blu-rays and spent $60.88, while Stephanie bought 4 DVDs and 7 Blu-rays and spent $46.96, both before tax. What was the average price for a DVD and for a Blu-ray? So here's what we can do. They've given us two equations, basically, Tyler's trip and Stephanie's trip. Okay, we have two unknowns, and I'll just say D stands for DVDs, and B stands for Blu-ray. Okay. So for Tyler's trip, Tyler brought 12 DVDs and 5 Blu-rays and spent $60.88. Stephanie bought 4 DVDs and 7 Blu-rays and spent $46.96. Okay, so there's my system. Should be the hardest part. Now that we have that down, we're going to try to solve the system. Okay, and this is both in standard form, so it's kind of set up to be solved with elimination. So if you like substitution better, I'm sure there's ways to use substitution, but this is where it's important to be able to do both so that you don't have to work harder than you need to. Okay, so I'm going to rewrite this top equation, 6088 of Tyler's trip. And then this bottom equation, I want to get this 4D into negative 12D so that I can get this canceled out. So I'm going to say minus 12D, minus 21B, and then 4696 times 3. 14088. That would be negative. Okay, so now I combine my like terms, or combine or add these two, that gives me 0. Gives me negative 16B equals negative 80. And so then I found that my Blu-ray costs $5. Pretty good sale. Or bad Blu-rays. Okay, and so I can find DVDs then by plugging it into one of the equations. I'm going to plug it into Stephanie's equation because the numbers are lower. Say 4D plus 7 times 5 equals 4696. So 4D plus 35, 4696. 4D equals 1196. 11.96 divided by 4, 299. There we go. And so the DVD costs $2.99. All right. Makes sense. Great Black Friday sale. All right, a couple more. Says I have 37 coins in my pocket, all quarters and nickels, totaling $6.05. How many of each coin do I have? So this problem and the coin problems like them, have a lot of information kind of packed all together. Okay, so a couple things we need to make sure that we understand is how much these coins are worth, right? And so for a quarter, it's worth 25 cents. We write that as a decimal as 0.25. And the nickel's worth 5 cents. We write that as a decimal as 0.05. Okay, now these get mixed up, especially the nickels. A lot of people will write 0.5, and that means half a dollar and not a nickel. Okay, so there's two ways to do this. You can either be really careful about that, or you can think of everything as just cents, and that helps us out a little bit too. So I like to think of everything as just cents. Even this, instead of saying $6.05, I'll just say 605 cents. And that way, when I write my equation, I can say, okay, with the amount of how much dollars are worth or how much my stuff is worth, I can say I have 25. Every quarter is worth 25 cents, plus 5, and every nickel's worth 5 cents. And together, that should give me 605 cents. Kind of took it for granted, but Q stands for quarters. And N stands for the number of nickels. Okay, all right. Now the amount of coins They said I had 37 coins in my pocket. So the number of quarters plus the number of nickels should equal 37. Now you can solve this problem any methods you want to, but I think it's pretty nice for elimination because this is 1n and 1q, pretty easy to get to the other side of this number, the opposite number that's given to us. So I'm going to eliminate the n's, and I'll do that by multiplying this top equation by -5. Or sorry, the bottom equation by -5. And so I get 25q plus 5n equals 605. Multiply this -5q minus 5n equals 150, 185, -185. All right, combine my two equations. That's 20q, and that's what is that? 420. I don't know. 605 minus 185. It is 420. Equals 420. Okay, so 420 divided by 20 should give us 21. All right, so 21 quarters. And so I'm going to use the second equation because that seems like the easier one to use here. 21 plus n equals 37. Subtract 21 from both sides, and I find that n equals 16. 21 quarters, 16 nickels. You can make sure that that works out if you'd like, and it should. 21 times 0.25 plus 0.8. So there we go. All right. A couple more here. It says Julie in her savings has $554 in her savings account. She deposits $12 per week into this account. Julie has a checking account of $770, from which she withdraws $15 per week. At this rate, how many weeks until her two accounts have the same amount in them? So here, I'm going to use A as amount of money in the account. And the other thing we don't know is the number of weeks. Okay, so in her savings account, we have two equations. One's about savings. The amount in her savings account is $554, where she deposits $12 per week. In her checkings account, the amount is $770, and she withdraws $15 per week. So there are two equations there. This is set up for substitution. Our variables are by themselves in both equations, and so it should be nice for substitution. And so in this first equation, I'm going to substitute 770 minus 15w okay, and then I'm just solving. So I add 15 to both sides, it gives me 27w. 770 minus 554 is 216. 216. All right. It should probably be like 8. 216 divided by 27. Divided by 27. And we get W equals 8. So in 8 weeks, she'll have as much in her savings account as she does in her checkings account. All right, final question here. It says, suppose you're trying to decide whether to buy or rent ski equipment. You find out that it costs $60 per day to rent ski equipment and buy a lift ticket. You can buy ski equipment for $400. A lift ticket alone costs $20 per day. If you planned on going skiing for 8 days for this winter, should you buy the equipment? So here we go. Looking at two things. Rent. It costs $60 per day to rent. 60 per day to rent and buy a lift ticket. you can buy ski equipment for $400 and the lift ticket costs $20 per day. All right, so here we go. The amount of money. So A stands for the amount of money that you're going to spend. And D stands for the days. And here's our system. If we rent it, we charge $60 a day. If we bought, this is what we get. So $400 for the equipment that doesn't change, and then $20 times the number of lifts. So here's how we go. We would say, okay, this is set up for systems of equations. Is set up for substitutions. So we could substitute, instead of using A in our second equation, we can use 60D. So we have 60D equals 400 plus 20D. Subtract 20D from both sides, and we get 40D equals 400. Divide by 40, D equals 10. So at 10 days, this would be the same. It wouldn't matter whether you whether you rented or bought your equipment. But the problem says we've got 8 days. Okay, and so with 8 days, 60 times 8 gives 480. 400 plus 20 times 8 would give us 560. So buying would cost 560. Renting would cost 480. Should you buy the equipment? Probably not. When would it be better to buy the equipment? I would say 10 days or more. If you skied, I don't know if that's how you spell skied, for 10 days or more. Right? Because if you spend 10 days, then you spend the same amount of money, and then you'd have also the equipment. And anything more than that, you'd save money. All right, so those are our word problems, setting them up, making sure that we are good with solving them, whether it's substitution or elimination. See ya.